Hello everyone, and in this video today I want to talk about types of parametric coordinates, and second I want to introduce two new VOP nodes. First, XYZ Distance, and second, Primitive Attribute VOP. In the last video I have already explained parametric coordinates in detail, but in this video today I want to talk about parametric coordinates types, right? And if you understand what are parametric coordinates, then it would be really easy for you to follow along with this video. So let's create our examples. I will review what are parametric coordinates. So in the last video I have already told you about that we have two spaces, local space and world space. So it's like you have a world and you have points in these 3D world, and they have their positions, right? So these 2 points have their position, but these 2 positions are according to the world, right? But we have, if these points are on a geometry, like we have a geometry and these points are on a geometry, now these 2 points have their positions along according to this world. But now what if I want to know their position based on the geometry they are on? That's how we have parametric coordinates, because parametric coordinates are point positions along in their local space. So we will review this note. Parametric coordinates are values usually 1 to 0 that describes a point position along a shape, not in a world space. So here I have wrote 0 to 1. That means if you have a geometry, then it would be like how much percentage of that geometry this point exists. In the last video I have explained everything. I guess it was about 20 to 30 minutes I took to explain the parametric coordinates, so I won't waste the time again. A percentage of shape, a coordinates in their local space, not x, y, z. And here we have u and v, where I'm on this shape instead of where am I in this world. Curve u is a parametric coordinates, and I will now explain what are different types of parametric coordinates. So focus now. When we understand what are parametric coordinates, their local point position, points position on their local space. But we have 3 types of parametric coordinates. First, bounding box parametric coordinates, and I have used bounding box as an example when we were working with the ramp, right? But I will create another example right here. Let's create a grid and rows 2 and column 2. So we would see something like this. We have this. Let's create an attribute VOP, so we can assign this a ramp. We can also assign a ramp in the vex, but we need relative to bounding box. We don't need to assign the ramp. Related to bounding box, we need the point position, and I want to give this CD, but I want, I will explain what I'm doing. I want a vector of float to vector node. And you can just connect this here, and we would have something like this. Vector to float right there. Sorry, I used the wrong VOP node. I mistyped float to vector, but we need vector to float. What is happening here? So to explain what is relative to bounding box, we did this in the last video when we were working with our ramp. Here I have connected the point position of the global geometry input. So now we are reading the point position of these 4 points. Now I have connected this into the relative to bounding box. What is bounding box? I have explained it like 3 to 4 times now. Bounding box is the imaginary rectangular box which it can fit the geometry inside it. So we need the uh, minimum area to fit the inside the geometry inside. And in this bounding box, this geometry now has a value from 0 to 1, 0 to 1. So this part has 0 value and this part has 1. These 2 points are getting values 1 and these 2 points are getting values 0. And I can open geometry spreadsheet and you would see that this 0 point is getting the value 0 and this 3 is getting 1 and also 0 because these points exist on the same part of the geometry. That's why they are having the value 0. I have explained this, and let's move further so we don't waste our time. I have this. This is relative to bounding box. Now this type of parametric coordinates. Now these points are getting values based on their local space, right? That is parametric coordinates. Now this is bounding box parametric coordinates. This type of coordinates are bounding box parametric coordinates. We are getting coordinates according to their bounding box. Now I have already created the curve parametric coordinates. Let's do it again. Let's create a helix. And helix is like this curve, and you can increase the turn if you want, decrease the turn I would say. And to understand this better, increase, I can decrease the points, but we don't need to, so add resample, so we can resample this curve. We don't need to understand this resample, and I have already told in the last video that we need to understand for now is curve view. Curve view is a type of parametric coordinates, and here I am talking about curve parametric coordinates. So this curve view is like, it is an attribute. We have this curve view attribute, and how it is working. Now it is assigning point a value according to their position along this curve. So this point is getting a value 0 and this point is getting a value 1, and you can like open this and you would see that this point is getting a value 0 and this point is getting a value 1. So every point that exists in between these 2 points will get a value according to these points. So if we have a line, let's do this with a line, you would understand it better. We have a line, we sample this, connect this, we have a line. You see the bottom point is getting a value 0 because it is at the bottom, and we have this u. Curve means a curve, u means its u coordinate. Let me explain. First, decrease its points. We have this. Now let's say 1 and 2, okay, and we can like do this. We can decrease the points number, I guess. Okay, now you would understand this better. Here we have this curve. Now we have this curve u attribute. U, I will explain in a bit. U, when I would jump into this, we would understand this u also. We have a u, which for now understand that it's from left to right, but we have only one we don't have any geometry here. Yes, it is a geometry, but we don't have any polygons, right? So we have this curve. So V means bottom to top. I will explain this, don't worry. But for now, understand this. U means like left to right, but this is a curve. So we have only the U value, not V value, because it don't have a thickness, a depth. It only is a curve. It only is a line. This is only a line, right? So we have these 3 points. So every point on this line would get a value, a curve U value from 0 to 1. 1 and 0, 1 and 1. And this point exists at the right, like at the exact middle of this line. That's why it is getting a value, half the value of this one, because it exists at the middle. So every point that exists on this curve would get a position value, a curve view attribute, which is like their position along in their local space. I hope you understand this now. Now let's understand these three in a bit more detail, right? So let's say you have this bounding box, right? This is our bounding box, right? First, let's talk about bounding box primitive coordinates. We have this geometry. So this end of this bounding box, this end of this bounding box will get a value 0, and this end would get a value 1. Everything inside would get a value according to these two values, let's say 0.5, right? So I have this geometry which is inside this bounding box. Now this part of the geometry will get a value from this, and this part will get a from value this. So every other point in this geometry will have their local position according to these two, right? This is bounding box. We have a curve. This point will get a 0, this point will get a 1. This is our left to right U value. This is our U value. This is a curve. Now every point on this curve will get a value according to these two. So middle point will get 0.5, and these two already have their value. So we are assigning point values according to their local positions, right? Now let's the main thing here. We have a primitive. We have a primitive. Now I want to talk about the primitive parametric coordinates. And here, the two VOP nodes that I told about you earlier, the distance XYZ node and the primitive attribute. And in this video, I want to introduce you with these two. And this is really important that we understand the primitive parametric coordinate first to understand those two VOP nodes, so we can like have a better understanding of these two nodes, right? So this is our primitive. It can be of triangle. We have right triangle and we have this random triangle, right? Now I told you about the x and the y. So parametric coordinates have values u, v, w. W is for volumes. W we use in volumes because it has depth, like depth. I will like talk about that also. But first, let's understand what is this u and v. Bounding box, we have this bounding box, this part and this part. We have 0 to 1, the u of this curve. But here, primitive, we have this u and this v and u. Okay, left to right is u and bottom to top is v. So this point and this point, this point and this point, let's say let's say you have this point here, this point here, this point here, and this point here, right? So this point will get a value left to right, 0 to 1 and 0 to 1, bottom to top and left to right. So this point will get a value 0 0, this point will get a value 1 0, this point will get a value 1 1, this point will get a value 0 1. When you see, we have something like this. This is our 0 0, this is our 1. So it's like a graph. This is our U, this is our V. So we are getting a value something like this. So if a point exists between this and this, like here, if I want the UV values, the parametric coordinates values, they're like local space values about of this point, we can have, like we can say it is in the middle of the our U coordinate and our Y coordinate. It is in the middle. So I would say 0.5 in X and 0.5 in the V, in the top, bottom to top direction. So now we have something like this, and you know now, like what is parametric coordinates? Point position at their local space. If we have a primitive, it was a square primitive. Let's say if we have a triangle, this is a triangle, right? It is a right triangle, so we can like understand this better, but it is the same. U, V, this is U, this is V. We have 0 0 1 1. So this point and this point will get a value 1 0, because 0 means in the V direction we don't have any, and this would say 0 1. But what about this one? You don't need to worry about that. And actually I am just telling here what are parametric coordinates so you understand them better, but we don't need to calculate the values. Houdini like do it by itself. I'm just telling you what are parametric coordinates because I think that we should understand the concepts, right? Let's say we have a triangle, and same 1, which is U, and V, which is like this bottom to top direction, and same 0 0 and 1 and 0. What about this one? It exists middle, so 0.5 of U and 1 of V, so it would get a value 0.5 and 1. This is U and V value. So these is our parametric coordinates. We have covered 3 types of parametric coordinates. Let's continue with our project. We understand what these types of parametric coordinates are. Now I want to introduce you to the XYZ distance and then a primitive attribute node, VOP node. First, let's create a line and let's create a test geometry. Pig head. Okay, I have this pig head, but I want this on top of this grid, so I would just give this a match size, not match axis, match size, and we have this right now. I don't want to explain this because I have already read, but we are now matching the geometry size to this let's say minimum, and to this box, and let's say scale to fit. We don't need to. I've explained about this in the I guess export video, export FPX file. I think it was my first or second video, but if you don't know about this match size, it is just like referencing this geometry according to this box. And when I said y minimum, that means the minimum part of the geometry would be the at the bottom of this box. When I say maximum, the maximum part would be, and when I say minimum, the minimum part would be. Okay, now we have this geometry and we have this line. I wanna attribute VOP. If you don't understand this, what I'm doing, like what is this attribute VOP, then you don't have to watch this video because you will understand nothing. Watch the first videos, like the videos before this one, because that then after then you can understand this, because I have explained these, and this is like really important that you understand what each node do before we jump into the video. Okay, so I have match sized it and connected this attribute input to. So we are now reading the attributes from this geometry, right? And this line is going in the first, so we are modifying or manipulating this geometry. And I want to say I want this line to be to be here and something like this. Okay, now I want to know what primitive of this geometry is the closest to this, and what primitive is closest to this point. What if I increase the points? But let's say first let's understand this. Okay, so I want to know which primitive of this test geometry is the closest to this one and to this one. Inside the VOP we have this VOP node, which is XYZ distance, and this VOP nodes, what it do, it like calculates the distance from the geometry you want, from the points you want, to the geometry you want to like calculate the distance from, right? I'm saying if I have this line, then these 2 points are now searching for the closest primitive of this geometry, but we need to like give the instructions by this node. I want the positions of this line to search for the nearest geometry. Like when we were working with I guess point cloud open, we had the exact same situation where we were searching for the points, for the nearest point, and we were searching from our geometry, from the geometry, I guess from the grid, right? So we were searching for the points. We are doing same here. We are searching, so we need to give this XYZ distance so it can know where these points are located, so it can now calculate the distance of the primitive, of the nearest primitive. So now we know where these points are located. Now we need to give this which geometry to look primitives from, like which geometry these points are calculating, like from which geometry we need to calculate the distance of the closest primitive. So we need to tell this which geometry. Input 2 from this global input 2. So now we have, because we have connected this geometry into the input 2, that's why input 2 into the input. So now these points are searching for the nearest primitive from this geometry. Now we have three outputs: distance, primitive, primitive UV coordinates. I have just talked about the parametric coordinates, and there I talked about UV coordinates, right? So now this is the same. This value is the same. If let's say if we have a plane, right? We have a plane. This is a square plane. We have 1, 2, 3, 4 points of this square. Now what if this plane is not perpendicular to the surface? It is like slightly tilted. if I have a point here, for this point, what is the nearest point of this primitive? This. We only have 4 points, but this part of this primitive is the closest to this point. So we need to calculate the UV coordinates of this part here. That's why we have the local coordinates. That's why we have uh, parametric coordinate values. So this is what is telling us that which part of the primitive is the closest to that point. We have primitive, which means primitive number, simply primitive number. Which primitive is the closest? It's just number. We have distance. What is the distance from the point to the primitive? And the distance is a float value. The primitive u is a vector because we have two values, and prim is an integer, right? We cannot have a primitive number in float. We cannot say 1.2 primitive because Okay, now we have these values, but this geometry output works on points. We are reading the points. We need something so we can read the attributes from the primitive itself. So we have primitive attribute VOP node. Now this node is used to read the attributes that are on the primitive, not on the points. This distance is calculating. These are primitive attributes. These attributes are on the primitive, on the faces, not on points. You see, geometry spreadsheet, we have 0, we have nothing, because they exist on the primitive level, but we need to read those first. So now we have this primitive UV. I want to assign those values to these points so they can snap to those points. What I mean by that, first let's disconnect this test geometry and let's create a, let's say, square. What's the box? Okay, connect this. Now these points are searching for the nearest and match size, right? And you can put this a bit down, and we have something like this. You can decrease the length also and increase the, let's say, here, right? And you can put it here so we can understand this better. And let's say okay, this is okay. Okay, now we know this node is outputting the value. Now this point knows what is the nearest point and the nearest primitive, because we have three values. We can output these values. This node has the values, right? Now we need to read those values. We cannot just say, oh, primitive number into the p. So these points will get this primitive number, not the exact distance and the primitive UV coordinate values. So what do I mean by that? What if I connect this into this? Now we are reading the primitive number. Which primitive is the nearest to these points? We have the number here also, but we cannot assign this number directly to the p, because if the number is, let's say, I have this box, right, and this box, okay, and I have 4 is the closest primitive to this line. If I'm saying merge them so we can see them both, now we have this floor. This is the closest primitive from this point to this point. This is the closest primitive. Same goes with this point also. Sorry, this face is the closest to this. So now what if I connect this into the p? What you will get? You will get 4. You will get 4 because 4 is the primitive number. but we want the distance. We don't need the primitive number. We cannot connect this directly, but we can read the primitive number. Now, what do I mean by that? Let me explain. We have the primitive number, right? Okay. What we need? This point, no. This is the closest point, but this point doesn't know which is the closest point of this primitive, like the UV coordinate. Like, what do I mean by that? Let me decrease the origin. When you like say, let's here. This is the closest point. This is the closest. This is the closest part. This is the closest part of this primitive to this point, right? This point is searching for the closest part of this primitive. This point also. When I let's move it side, okay. So now so we need to read the closest part also. And how can we read that? The primitive UV coordinates, right? The part, their points, their like positions on this. So if I'm saying where is this 4 located? So you can have the exact answer. You can have the exact answer. 0, 0, right? From left to right of this primitive, 0 to 1. 0 to 1, 0 to 1. Now 0.5 of the x, u, and 0.5 of the y. So we have this 4 at 0.5 on this primitive. We know its position. But what about this and this? We need those UV primitive values also. We are telling this point, which is the closest point, closest primitive, sorry. 2 is not the closest primitive, right? That's why we need that 4 value. That's why we need that 4 primitive number, so we can know which is the closest primitive, right? So we need that closest primitive number. Also, we need the closest point on that primitive, not just the primitive. We need that UV coordinate of those points. Which points? The points which are closest to these 2 points. When I like give this value to the P, you would see it is now gone. Here you have to tell this which attribute to read. Primitives have CD, primitives have like their normal values, but we need to give this like we are reading this nodes. No, we are reading the primitive, we have the UV, but from which attribute? So we need to give this a P attribute, their position, so we can like put it into the P. Now when I see this, you would see something like this. I forgot to tell you something. When we connected those values into the P position, so we have the primitive number and the primitive UV coordinates of that closest point, right? But we didn't give this from which geometry to read these from. Let me explain. This primitive UV, primitive attribute, knows 2 things of this position P attribute. And this position P is coming from this primitive number, which is primitive 4. This is the closest one to this line. Where is this line? Let's say this is the closest primitive to this line, and disconnect this. This is the closest number to this line, closest primitive, and this knows 2 things. This only knows 2 things: primitive number and its UV coordinate. But we need to tell this these are from which geometry. This doesn't know from which geometry these are from. So we need to give this the geometry to read from, and when we say P, you would see something like this. It will get attached to their closest points on the primitive, and by the primitive number, by the UV, from which geometry, from this geometry input, we would have something like this. When I increase the points, you would see something like this. But what if I connect this instead of this? this line would attach to their closest primitive coordinates. And you would say, this looks like distorted. Yes, and because when you say line, and when I change its position into the x and the y, and you would see something like this, because when I merge them, but when I disconnect them, you would see the closest point, the closest primitive to this point is which? We have two. So the closest one is this, I guess, right? You can say yes. The closest one is this here or something like it here. I don't know because I can only guess, but you would see this primitive is like this. So closest position is this, so we need that UV coordinates of the primitive also. So when I connect this into this, you would see the closest primitive points are here. So it is attaching to this. So this point is for this point, this is the closest point where it attached. So let me sum up what I told about, what I shared in this video, what I talked about in this video. First, we talked about the different types of primitives. We have curve U, which is a parametric coordinates, right? Second, we have our bounding box parametric coordinates, and third, we have this UV primitive parametric coordinates, and whose values are in U and V, right? Okay. And we talked about our XYZ, which what's the word? Which calculates the nearest primitive distance, and it gives the nearest primitive value, and it also gives the primitive UV coordinate exact point on this primitive closest to that point from where you are searching from. And we have this primitive to read the primitives from a geometry, and the primitive number and the primitive exact UV, and we can now give this value into the P. So these points are getting the value of these primitives closest point to this line points. So I hope you understand about these, because in the next video I will use these three and I will create a deformer, like we can deform a geometry according to different geometry. So I'm something like this, I will do the same, but we would create a proper deform geometry. So this is it for this video, and I will see you in the next one.